All right, now, yesterday, what were the two things that we were looking for? We were looking for two things. No. Finding zeros and, can't hear you, Blaine, speak up. Riley?
The axis of symmetry.
Yes, yesterday we were looking for zeros and the axis of symmetry. So, now today, we're going to be learning how to find the vertex of a quadratic function. Now, who can tell me what the vertex is? Carly?
The turning point of the parabola?
Yep, so just all quadratics either open up or down. The vertex is the very highest point or the turning point where they graph. So
Or the very lowest point.
or the lowest point. So it either goes from decreasing to increasing or vice versa. So, today we're going to be actually finding the vertex from a function that we're given. So, first thing we have to do, we have to find the x value of our vertex. And we can do that by finding the axis of symmetry. Now, if you guys remember yesterday in our notes, the axis of symmetry and vertex are related to each other. So how are they related to each other? Ricky?
The axis of symmetry runs straight through the vertex.
Exactly. The axis of symmetry always passes through our vertex. So if we have an axis of symmetry that had an equation like x equals 4, the x value of our vertex would be what? 4. Because all points on our axis of symmetry have an x value of 4, right? Alright, so that's how we find our x value. Once we do that, we can get our y value by substituting in the x value that we just got. Substituting. Right, so when we find our axis of symmetry, we're finding the equation for the line of our axis, but we're also finding the x value for our vertex. And since it is an x value, you can treat it like all other ones and just plug it straight into our function. Yes, Carly?
No, I want to answer.
Oh, you want to answer it? All right, now, once we get our x value, we can get our y value. After that, we're going to write our vertex as an ordered pair. First problem here. We have the function y equals x squared minus 4x minus 10. So we have to find the vertex of this function. So, anyone remember the formula that we did yesterday? Morgan? X equals negative b over 2a. So that formula right there, that is how we find our axis of symmetry. So they have a b and a value in there, right? So we need to have those two, right? So we have a and b. What's a and b for this one right here, Riley? 1 and negative 4. That's all right, so we just substitute all our a and b in there. So we have negative, substitute negative 4 in for b. 2 and 1 goes on bottom. So when we simplify this out, it gets to x equals what?
2 over 1.
Riley?
4
over 2.
Right, so the negatives cancel out on top. 4 over 2. And this one, 4 divided by 2 is 2.
the vertex?
Nope, that is an x value for our vertex. This is also the equation for our axis of symmetry. Yes, Christian?
So then you would put x in for the problem.
Now we do what?
You put x in into the problem.
So we have y equals x squared minus, not 2 4s.
Minus
4x minus 10. Say that again, Christian.
10. You would substitute 2 for the x variables.
Exactly. We found our x value. Now we just plug this in, the x value, or 2 in for the x's. So we have y equals 2 squared minus 4 times 2 minus 10. So we got an x value, we plug that into our function, and we're going to get a y value out of it. 2 squared is 4. 4 times 2 is 8. There we go. 4 minus 8 is what? Negative 4. Negative 4 minus 10. Oh, what should we have, Michaela? Negative 14. All right.
That seems like a lot of work for a problem.
All right, so
So that's the,
that is the y value of our vertex.
that's what the problem is asking, right? That's what we're supposed to.
Yep, so problems will ask you to find the vertex of a function, and you'll do this work. You'll find your x value first. You'll use that to find your y value. And the last step is to do what? As an ordered pair. So this one should be 2, negative 14.
Fine.
All right.
That's a lot of work for one problem.
Ricky, feel free to graph the parabola instead and see if you can, and find the vertex that way instead. Okay, we'll give you permission to do that if you would rather.
No, thank you.
So we want a visual of it. Which way do you think this function is going to open up or down? Why? Because a is positive, right? So just a rough sketch of it, it's going to look like this, right? And our vertex is right here. So, first part we did, what did we found the x value to be 2, right? So what did we also find when we did this? The line of symmetry, right? So we can put a little dashed line that goes right through it. So what will the equation for this axis be? Found it. X equals 2. So the equation of this line is x equals 2. So every point on that line has an x value of 2.
Show what's x equals 2 on the arrow. I think that would be.
There we go. So since this vertical line is x equals 2, every point on it has an x value of 2. So then, let's do that one. So that one has an x value of what?
2.
2. And then the second part, we found its y value to be negative 14. There you go. That's just a rough visual of what it would look like. Yes, Sam?
Do we have to,
No, you don't.
I recommend you have to do your notes though, please, because of the final.
If you don't have that rough sketch in your notes, take a second to do that now. All right, anyone still need this up here? All right then. So, quadratic functions, or models for them, they're actually more common in your everyday life than you think. Like in basketball, like that first problem we did in the day problems, when you shoot a basket, it has an arc on it. In football, same thing, when they throw the ball like a Hail Mary, maybe not short passes, but whatever. So those are all representing quadratic functions. Same with bridges and roller coasters, all kinds of things. So everyone open your books. Page 534. Alright, and we are going to do check it out problem number 5 at the bottom of that page there. So does someone want to be brave and read that for the class? Isaiah? Thank you.
The height of a small rise in a roller coaster track is modeled by f of x equals negative 0.07x squared plus 0.42x plus 6.35, where x is the horizontal distance in feet from a support pole at ground level. Find the greatest height of the rise.
All right, thank you. All right, so in this problem, it says we're on a roller coaster. We're not on it. There is a roller coaster. It'd be more fun if we were on it, but so there's a roller coaster. X is representing horizontal feet from a support pole. So like, I'll just draw a rough sketch. Here's where it starts. Here's the pole. After some time, we start going up and up and up and up. So we're asked to find what for this problem? Carly?
Greatest height of the rise.
Right, so we're asked to find the greatest height. We're asked to find this point right here, the very highest point of this small rise that we're going on in this roller coaster.
So vertex?
Exactly. We're looking for the greatest height of the rise or the maximum of the function, which is also the vertex or the y value of it, excuse me. So how would we find the y value of it? And we do what we just did on the front side, we have to find the vertex of it. So we use that formula again, x equals negative b over 2a. We still need a and b for those things, we can't just pull them out of thin air. Riley, what's our a and b?
Negative 0.07 and 0.42.
Thank you. Oh, it looks like. There we go. Okay, so we have an a and b value. We have our formula. So we can just substitute everything in. So x equals, what goes upstairs?
Negative 0.42.
Negative 0.42. Downstairs is 2 times our a value. So upstairs we have negative 0.42. Downstairs we'd have what? Cole?
Wouldn't it be a positive 0.42 because it's negative b and it's already a negative?
Mm-hmm.
It wasn't negative though.
So right there.
It was negative.
It's negative b, the negative is out there by itself.
Yeah.
So then we substitute whatever we found for b, so 0.42, that's why we put it in parentheses.
Like being
Okay.
Okay?
That was.
All right.
Yeah.
All right, so downstairs, what do we have? Just a 0.14.
Negative.
Negative, there we go. All right.
But
So it's negative 0.42 divided by negative 0.14. An easy way to think of it is how many 14s are in 42?
couple.
3. So this one should be x equals 3.
Negative? No.
Nope.
I still can't
All right, so we found our x value of our vertex, right? That's what we did on the front side. This is what we're doing here. Then we just do the same thing that we did there. So we have y equals negative 0.7 x squared plus 0.42x plus 6.37. So we have a function that they gave us. We have an x value that we can plug into it. So we just substitute in whatever our x value is for any x there. So squared. I'm just gonna do this one step at a time. So what's 3 squared? 9.
Oh, yeah, I don't know the original.
So 0.42 times 3 is what, Sam? 1.26, thank you. Alright, and this last step here, 1.26 plus 6.37. Hmm? You're in 7, 6, 3. Alright. So, is everyone with me so far? Yes, William?
No. It's still 7.
Okay. So when we have negative 0.63 plus 7.63, what do we get, Blaine? 7. So we have an x equals 3, y equals 7. So what would the order pair for our vertex be then? 3,
Yeah.
7. But is that what the question is asking us for? What is it asking for?
Velocity.
No.
Like right like that.
The greatest height of the rise. So if we want to write this out in a sentence, we could say that,
We will write it out in a sentence.
there you go. The greatest height of the rise is what? 7 what? 7 monkeys?
7.
7 feet. Yes.
7 feet. There you go. Mhm.
Well, that's not very high. That's a baby roll.
That's just a little taller than me, actually. Like 6 inches.
Wow.
Alright.
Yeah,
This is probably near the end of the
That's
road.
that is a kitty.
Alright, so the height of this small rise, it was just a little one, so it's probably at the end of the roller coaster. So the greatest height of it, or the maximum of this rise, is 7 feet.
Maybe it's a kitty coaster.
Maybe it's a kiddie coaster, there you go. So we found the vertex of it, we found its x value, we use that to find its y value, and that y value is what we just found, the greatest height of that rise. So, anyone have any questions? Yes, sir.
So we're gonna have to do all this in our homework?
Mhm.
Is this only what we're doing, or is it?
Yes, Isaiah?
You need to have the drawing put on the print.
No. So in your homework, what are you finding first?
X.
The x value, then you're using that to find what? The y value, then you should have a
Fair.
ordered vector. All right. Yes.
Can I correct that?